Good afternoon, everyone. We are students from the University of Basra, Department of Mechatronics. This presentation is for the static course. My name is Fatma Ghazwan Jawad, and my team are Hussein Osama, Minar Hisham, Muntadar Basim, Zainab Bashir, Hussein Aqi, Sarah Haider, Fatma Ali, and Zahra Sabah. In this presentation, we will explain the project idea, the problem statement, the system description, the static analysis, stability analysis, and result. Finally, we will present the electronic warming system and the conclusion. Project idea: we designed and built a 16 cm scaled engine crane capable of lifting weight between 5 to 8 kg. The project integrates mechanical design with an Arduino Uno system and MPU 6050 sensor to create a smart lifting environment. Why we choose it? We choose this project because crane topic is a major safety hazard in construction state. We wanted to move from textbook static to a physical model that help us understand the limit of stable and the exact point where the crane fails. What makes it unique? Unlike standard models, our crane has an active wiring system. It doesn't just sleep, it calculates once the boom angle exceeds 55 degrees. It triangles a buzzer and an LED. This smart feedback allows the operator to stop before the crane tips over, making it much safer than traditional design. Problem statement: why crane fell. A crane must remain stable while lifting a load. If the load is too heavy or far from the crane base, the crane can become unstable. Center of gravity. The center of gravity is the point where the crane and load are balanced. If this point moves outside the crane supporting area, the crane will tip over. Main causes of crane failure. Bad ground. If the ground is soft or uneven, the crane leg will not be supported properly, which can cause loss of length. Strong wind. Strong wind pushes the crane and load, reducing stability. Overloading. Lifting a load heavier than the crane's stability increases the risk of topping and structure failures. Operational errors. Most crane accidents happen due to simple mistakes such as not checking the ground condition or misjudging the load weight. System description. The Smart Mini Crane system is made of three main mechanical parts: the base, the column, and the boom. The base is the bottom part of the crane and it is in a contact with the ground. Its main function is to support the wheel traction and resolve the overturning moment. Column. The column is the vectory element fixed to the base and it transfers the load from the boom down to the base. The boom. The boom is an enclosed arm that carries the suspended load using a chain. The angle of the boom can be changed, which affects the distance of the load from the base. As an angle increases, the overturning moment also increases, and this behavior is analyzed using static principle to study the stability of the crane.
In this project, a simple electric system was implemented to support the mechanical analysis of the crane and enhance safety. The first component of the system is the Arduino Uno. It's the main control unit of the system. The second component is MPU 6050 tilt sensor. It continuously measures the crane arm angle. The third part is a critical angle detection. The system detection a critical tilt angle that is unsafe. Fourth, wiring activation. When the angle exceeds the limit, LED and buzzer alert the operator. Finally, the electronic system only monitors and wires. It does not control the crane movement. This slide shows the stability result of the lifting arm system. System stability depended of the arm's tilt angle and applied load. As the arm raises aloud, the center of mass shifts outward, increasing the risk of tipping. The system can detect unstable conditions early, preventing tipping and overload. Combining electronic sensing with the mechanical structure improve operational stability, safety, and reliability. In this slide, we applied basic static analysis to study the lifting arm. We started by defining the main parameters of the system, such as the applied load, the arm length, and the support angle. The load creates a force acting downward on the arm, and this force generates a torque about pivot point. As the torque increases, it directly affects the stability of system. Therefore, the side support must be strong enough to resist this torque and keep the system stable. The final result shows that the structure can safely handle the applied load under static conditions. In conclusion, this project demonstrated the importance of static in analyzing lifting system stability. We showed that instructing the arm angle increases the risk of overturning, especially beyond 55 degrees. To support this analysis, an electric wiring system using the Arduino Uno and the MPU 6050 sensor was implemented. This system provides early visual and audible wiring, improving safety and reliability. We hope you enjoyed our presentation on the Smart Electronic Hoist.